All right, so I am back for the second of this. I got I did some moving around and I feel ready to come back. So let's do this here. All right, uh, relational operators. A relational operator checks how one operand's value relates to another, such as being greater than. Some operators, such as greater than or equal to, involve two characters. A programmer cannot uh, arbitrarily combine the greater than, equals, and negative, less than symbol. Only the two character sequence shown represents valid operators. So less than, greater than, less than or equal to, or greater than or equal to. And then we can see examples here. If x is 3, x is greater than or equal to 2, it's true. If x is greater than or equal to 3, then this is true. Now, if this equal sign wasn't here and it said like x is less than or x is greater than 3, or 3 and 3, this would actually be false. Um, the equal to operator there makes it true. Let's see, x is greater than or equal to 4. It's false. So you get the idea. Um, sorry, I lost my place here real quick. Okay. Indicate whether the expression evaluates to true or false. X is 5, y is 7. So x is less than or equal to 7. It is less than, so definitely true. Y is greater than or equal to 7. So 7 is equal to 7, so this is true. This is not a valid expression. Is x greater than? This is not an expression, a correct expression. It would have to be switched around like it shows here. Type the operator to complete the desired expression. Num_dogs is greater than uh, 10. Now, it is greater than, but I have a feeling that it wants us to use the expressions that we just learned. So I'm going to put an equal to. So greater than or equal to. Okay, so that's awesome because it doesn't want that. It just wants the greater than. Sometimes the way they word these and sometimes the way they do these is kind of confusing. So numcars is greater than or equal to 5. So greater than or equal to 5. Numcars is 5 or greater. So basically it's like saying greater than or equal to. Loss is a negative number. So that would be less than. Whoops. Detecting ranges with if-else statements. Programmers commonly use the sequential nature of the multi-branch if-else arrangement to detect ranges of numbers. In the following example, the second branch expression is only reached if the first expression is false. So the second branch is taken if user age is less than 16 is false. So 16 or greater, and user age is less than 25, meaning user age is between 16 and 24, inclusive. Okay. The user enters 27 for their age, which is stored in memory as the variable user age. The multi-branch if-else first checks if user age is less than 16, which is false. The next branch In the multi-branch, if else checks if the age is less than 25, which is false. The next branch checks if user age is less than 40, which is true. The else statement executes and the variable insurance price is set to $23.50 in memory. So here, each so the if and each elif statement checks to see if they're true, less than, less than, less than. Otherwise, if all these were false, insurance price would be $2,100. Type the type the range for each branch. Type ranges as 25 to 29 or plus 30 or 30 plus. Second branch range. So that would be this one here. So this one is covering 0 to 9, and this one is covering 10 to 19. Third branch is covering 20 to 29. And the fourth branch is 30 plus because it already covered ages 10 to 19, 20 to 29. Now it's going to do any age. The else is going to cover any age of over 30. What is the range for the last branch below? So less than, so basically -1 or 0, yeah, -1 to infinity. And then this would be elif. So I think this is going to be 0 to, why did it do that? I didn't even enter anything yet. Jeez. 0 to 99, I believe. No? For the last branch. Oh, last branch. My bad. That's actually going to be 101 plus. Last branch, right? What is the range for the last branch below? So this is covering all the negatives up to -1. This one is going from 0 to 99. Oh, okay. Yeah. And then 100 plus, probably. 0 to 99. And this is covering 100. 0. What does it want from me? To 99. I mean, it's not 0 to 99 because this one's covering 0 to 99. It's 100, and that is, so it's greater. So no, that's saying greater than 100. So 101 to a plus infinity. So it's actually, oh, not right. 0, the negative numbers, and this is covering a 101 or 100 plus, no, 101 plus. So I typed in 0 to 100 and it told me it was wrong. The fuck? I mean, I did 0 to 99 first. The first expression of the numbered items less than 0 must have been false. Num items 0 or greater, the second expression of numbers is greater than 100 must have been false, meaning um, num items. So, oh, is it because this is actually covering 101 plus, and this one's covering 1 to 100? That's why. That's more than likely why. Second branch. User num is less than 200. If user num is less than 100, elif less than 200. Is that what it's wanting us to do? It's wanting to do the expression. Oh, it's wanting us to write out the whole thing. So elif user num is less than 200. If user num second branch user num is positive, so non-zero, so greater than 0, right? Yep, not equal to 0. Oh, okay, so you could do that expression as well, or this expression as well. If user num, so if second branch user num, 1 second. Sorry about that. Thought my cat was stuck behind the door. All right. The second branch, user num. So elif user num is greater than 105. Final else branch executes. What must user num have been? So if the numbers were, if user num is less than or equal to 9, failed, and then this expression, elif user num is greater than or equal to 11, else user num is greater than or equal to no, yeah, to 10. 10. Let's try that. User num is greater than 9 and less than 10, 11, then either of the first two branches will execute. So between 9 and 11 is 10. Oh, what if I do equals to 10? Like that. Right? Because this is covering everything from 9 below, and this is covering everything from 11 and up. And the only number left between that is 10. I mean, 11 to infinity is already covered. Oh, so just 10. I mean, I had the number 10 right. I guess I was just confused on what it was asking me for. Okay. Which branch will execute valid answers 1, 2, 3, or none? So that's not less than 0. Um, that is not greater than 666. Else, so it's not less than 100. So none. Okay, let's go ahead and start this. Okay, so if the input is 10, if 10 is greater than 5, which is true, that would be P, right? And then S. And it is a print, so I'm going to enter. Oh, it's each printed out, so it would actually be like that. So it does do one print and then a second print, which puts it on a new line. Something is like getting me. Okay, so less than 15 is true. So Q, print Q, and then that's actually it because there's no following, nothing executing afterwards. So, but it is less than 30 and it is less than 50. However, the first expression was true, so then it's going to stop all these and ignore those. Less than 15, false. Is 34 less than 30? No. Is 34 less than 50? Yes. So you're going to print N, return. There's nothing else to execute, so we'll check that. That is correct. Less than 30. Okay, so 30, so less than or equal to 5, that's false. Less than or equal to 30, that's true. So D, that's correct. 11. Is 11 less than 10? No. Is 11 equal to 10? No. Is 11 less than 25? No. Else print C. Uh, oh, I mean, yes. 11 is less than 25. Dumbass. Okay, so 28. Is 28 less than 15? No. Is it equal to 15? No. Is it less than 25? It is not less than 25. So then J would be the output. Correct. Python supports operator chaining. For example, A is less than B less than C. Determines whether B is greater than A but less than C. Chaining performs comprehensive left to right evaluating. A is less than B first. If the result is true, then B is less than C is evaluated next. If the result of the first comparison, A is less than B, is false, then there is no need to continue evaluating the rest of the expression. Note that A is not compared to C. Oh, it's not compared. No, it's not. So it's not saying less than or equal to. Write a relational expression using operator chaining. Okay. So X is less than Y, but greater than Z. Is that how you would write that? So let's check that. That's incorrect. So it would be the other way around. Just checking to see. So for example, A less than B less than C, so determines whether B is greater than A but less than C is less than Y, X is less than Y but greater than Z. Oh, because the expression needs to come back true, right? No? X is less than X is less than Y greater than Z but greater than Z. Oh, so maybe it's like this. So X is less than Y, right? But greater than Z. So this should actually be like this. Yep, that's correct. X is a non-negative number less than 100. X is a non X is a non-negative number less than 100. So is it just asking me to write the expression like that? X is a non-negative number. So X is greater than or equal to, because it's not a negative number. X is greater than X is greater than or equal to 0, less than 100. I mean, so am I saying 0 X 100? Okay. Oh, okay. So equal to X. So X is a non-negative number that's less than 100. 0. Oh, but it's not negative, so you have to do less than or equal to X, which would, if it was a negative number, it would, well, it can't be a negative number itself, but it is a non-negative number. Less than. Has to be false in order for X to be greater than 0, but less than 100. Yeah, okay, that makes sense. Variable user grade is read from input. User operator chaining to complete the if-else expression as follows. If the value of user grade is between 9 and 12, both inclusive. If the value of user grade is between 9 and 12, then in high school's output. Otherwise, not in high school's output. Example 1, if the input is 10, then the output would be in high school, because 10 is between 9 and 12, but 8 is not between 9 and 12, so not in high school. So 0x5 evaluates to true if x is between the range 0 and 5. So it wants us to write an expression here. Variable if is read from input. Use operator chaining to complete the if-else statement structure. Okay, so if the value of user grade between 9 and 10 is less than 9, no, yeah, less than 9, but and 9 is greater than user grade but less than 12, then in high school, right? Oh, it wants us to say, no, yeah, else. I mean, it's saying otherwise. Okay, so if the value user grade is between 9 and 12, right? So that means what? User grade is between 9 and 12. So what if we do 9 is less than, oops, 9 is less than user grade, right? But greater than 12. No, I mean, user grade is greater than 9, but less than 12. So it puts it in between. Okay, so the output not in high school is correct. So, I mean, can I change this to, oh no, I have to write it here. So how can I make it to where it also says in high school? So if value is between 9 and 12. So this is between 9 and 12. So 9 is less than user grade. I mean, not, yeah, 9 is less than user grade, and user grade is greater than 9. But why is it? What am I missing here? I mean, even if I switch this around, that would still come back the same, right? So 12 is less than grade, but greater than 9. I mean, that doesn't make sense. That can't be right. But it is putting 12. Oh, it's both non-inclusive, so it's actually going to be 13 and 8. That's why. Yep, that's what it was. So they were not inclusive. Um, the second branch outputs greater than or equal to 50 when the value of user num is greater than or equal to 50. The second branch outputs greater than or equal to 50. Okay, so the second branch, so outputs greater than or equal to 50 when the value of user num is greater than 50. Fill in the expression for the first branch that outputs less than 50. So is it saying that if less than 50, so if user num is less than 50 and 50 is greater than user num, but I mean less than 50, right? Otherwise print greater than or equal to 50. I mean, if I said this, if the number was greater than or equal to 50, but because if it's less than 50, if that's false, then it would have to be greater than or equal to 50, right? Yeah, okay. I think I was just reading too much into it. Write an if-else statement to output at least 51. If the value of inval is at least 51, otherwise output less than 51. So write an if-else statement to output. So it's going to want us to do print at least 51 if the value of inval is at least 51. So greater than is greater than 0, no, sorry, at least 51, right? So else print if the value is otherwise output less than 51. Right? So what does the expression have to be in order for an example? So if the input is 52, then the output is at least 51. Okay, so that would mean like, I mean, it would have to be something like less than uh, or I'm sorry, no, it's yeah, at least 51. It's 52 because it would maybe it's greater than or equal to, right? 51. Oh, it's less than 50. So expected. What did I miss? Oh, I missed the colon. Need the colon there. Yep. Okay. So less than or greater than or equal to 51. Integer number of gerbils is read from the input if number of gerbils is greater than 16. Is greater than 16. Output print too many gerbils. Perfect. Integers user val and new val are read from input if user val is greater than or equal to 126, then assign new then assign new val with 100. Oh, 1000, not 100. Okay. Integer visitor count is read from input if visitor count is greater than or equal to 11, then print enough visitors. Otherwise, so else print not many visitors. Okay. Whoops, I don't know why I hit check twice. Okay, perfect. Final level. Integers, item count, accepted groups, and invalid groups are read from input. If item count, so if item count is greater than or equal to 24, then add 5 to accept. So accepted, right? Yeah. Groups will be, we'll add 5, right? Add 5 to accepted groups, else subtract 3 from, so invalid groups, subtract 3 from invalid groups, so invalid groups, so we'll do minus equals, so that way it will subtract 3. Let's check that. Perfect. All right, done with that. Okay. Here's the last one of 5.4, detecting ranges with branches, and then we'll move on to detecting ranges with logic operators. So when the input variable brightness value is when the input variable brightness value is less than or equal to, sorry. Okay, so less than or equal to 685, output too dark. So if brightness value, so less than or equal to 685 is less than or equal to 685, then we will print too dark between, so elif brightness value between 685 exclusive and 2, whatever that range is, output satisfactory. Okay, so I would say brightness value is less than less than uh, 685, right? But 685 is and greater than, but greater than brightness value, and less than 228, 22.8, right? Print Come on. Satisfactory. Satisfactory. So between 685 exclusive and 228 exclusive. Oh, so this would actually be, I think, 9. So if brightness is less than 685, and 685, no. So is it saying less than 685 and 685 is greater than brightness? Or is it just saying it's checking to see if 685 is greater than, right? So 684, since it's exclusive, or is it exclusive? No, not, yeah, it's not inclusive, it's exclusive. No, then that means it would be 85 and 28, I believe. We'll test it, we'll see. Greater than or equal to 282, output too bright. Else. I mean, because if it's less than that and in between that, then I mean, else would be have to be, greater than, right? So print to right. Let's test this. I want to see what this comes out to. So this came out to input 684, too dark. Okay, so that's correct, but output differ. So this one was supposed to be your output is too bright. So satisfactory is what it needs to be. Or I could do, what if I do LF brightness value is greater than or equal to 228, right? This might have to be 20. Should be 20, no? 227. 227 comes out to. So greater than or less than 227. So would it be 227 then? Right? Because this is saying between, right? So my satisfactories, I've got something wrong here. Oh, maybe it's actually 685 is less than brightness value, but brightness value is greater than 685 and less than that, so that would put the brightness value in between. So maybe that's what I'm doing wrong. Okay. So, okay, so that looks good. Okay, I'm gonna take a quick walk around and I'll be back. Okay. So local and or not general. Okay. Sorry, I had to get comfortable. Okay. Um, Logical and or and not general. A logical operator treats operands as being true or false and evaluates to true or false. Logic operators include and or and not programming languages. Not. Programming languages typically use various symbols for those operators. Oh, come on. For those operators, but below the words and, or, and not are used for introductory purposes. Okay, so let's take a look what it's doing. And evaluates to true only if both operands are true. So A, B, if A is true, B is true, and A is true, right? A and B. Or evaluates to true if any operand is true. One, the other, or both. Okay, so this is saying this can only be true with and this can only be true if both of these are true. And this is saying if either one is true, then this has to be true for or. Not evaluates to the opposite of the operand. So if so A is false, then it's not, it's true. Okay. Each operand is an expression. If x is equal to 7, y is equal to 9, then x is greater than 0 and y is less than 10 is true and true. So the full expression evaluates to true. Both operands are true. So um, x is greater. So x is 7, y is 9. So x is greater than 0, which is 7, which is true, and y is less than 10, which is true. So this statement is true. X is greater than 0, so 7 is greater than 0, which is true. And 9, y, is less than 5, which is false. So that makes this false because they both have to be true with and. X is less than 0, that's false. Y is greater than 10, that is false as well. So this is false because one or the other has to be true. Um, X is less than 0, 7 is less than 0, false. Y is greater than 5, that's true. So because we're using or, only one of them has to be true. So this is true. Not. So X is less than 0. So it's not less than 0, which is false because it is. Not. X is greater than 0. So 7 is greater than 0, that's true. So is not, so it's saying it's not greater than 0, but that's false because it is. So A and B, so logical and true when both of its operands are true, or is true when at least one of its operands are true, and not true when its one operand is false, and vice versa. Indicate whether the expression evaluates to true or false. Okay, so x is 7 and y is 9. X is greater than 5, that's false, right? Oh, 7 is greater than 5. I don't know my numbers, I guess. Or I'm just not thinking and I'm rushing. So let me slow down and, you know. So x is greater than 5. So 7 is greater than 5, right? So x is greater than 5. So that is true. So 7 is greater than 5. So and y is less than 20. And that's true. So this is true because they're both true. 7 is greater than 10. That's false. So, and because it's an and, it automatically fails because both of them have to be true. X is greater than 10. So 7 is greater than 10. That's false. And then we have the or one here. So y is less than 20. That's true. So with or, only one needs to be true. X is greater than 10. So 7 is false. And 7 is greater, or 9 is greater than 20. That's also false. So both of them are false. So it's false. 7 is greater than 10. So 7 is not greater than 10. That's false because, I'm sorry, that's true. 7 is not greater than 10. Not. So x is greater than 8x is greater than 5. So 7 is greater than 5. So not greater than 5, which is false. And y is less than 20. So I feel like because of the not, it's going to be opposite. So I'm going to say false because this does equate to true. Yeah, okay. I think it even says it here. X greater than 5 and y less than 7 evaluates to true because both of them are true, but not true evaluates to false. So it's the opposite. A common use of logical operators is to detect if a value is within a range, using and to detect if a value is within range. The range 10 less than x less than 15 means that x may be 11, 12, 13, or 14. Okay, that makes sense. Specifying the range in a program can be done using two less than operators along with an and operator. 10 is less than x defines the range, 11 and higher. Right? So 10 is less than x. Oh, okay, so it has to be less than 11 plus. X is less than 15 defines the range 14 and lower. And anding yields the overlapping range. Only when x is 11, 12, 13, or 14 will both expressions be true. So x is less than, or 10 is less than x. So it has to be 11, 12, and then and x is less than 15. So this is pretty much saying in between, it has to be in between these numbers here. Right? Because x is less than 15, so that means any number on this side. But then it has x is less than 15. So it has 14 to 9. I mean to 11 is pretty much what it's doing. Okay, sweet. Assume x is an integer. Which approach uses a logical operator to detect if x is in the range 1 to 9? So 0 is less than x. Determine if x is in range. So 0 is less than 1, but 1 is greater than 0, and x is less than 100. So I'm going to say this one. because 0 is less than x and x is greater than 100. I have a feeling it's this one. Oh, okay. Maybe I'm thinking of it wrong then. X is in range of 1 to 99, right? 0 is less than x and x is less than 100. Oh, 0 is less than x. So that would cover 1 on up. And then x is less than 100, and that would be, so basically 1 to 99. So this one, yeah, okay. Which approach detects if x is in range -4 to +4? So x is less than -5, so everything from that side, and x is less than 5. So those are not inclusive, so I'm going to say this one. Which approach detects if x is in the range? So x is greater than, oh, okay, greater than because it's negative, so it's going to go the opposite. So it's greater than, and less than will make it go like 4, -4, 3. So it'll actually be greater than 5 and less than 5. Okay, so it'll actually be this one. I just counted this one wrong. Which detects if x is either less than -5 or greater than 10. So x is less than 5 or x is greater than 10. And it kind of tells us here, right here, or. So Booleans and logical operators. A Boolean refers to a value that is either true or false. Note that true and false are keywords in Python and must be capitalized. A programmer can assign a Boolean value by specifying true or false, or by evaluating an expression that yields a Boolean. My bool equals true, assigns my bool with the Boolean value true. Is small is assigned 4 is less than, assigns is small with the result of the expression 4 is less than 3, which is false. Oh, okay, so false. This is going to give this false. Interesting. Keywords and or and not, lowercase, are used to represent the and or and not logic operators. Logical operators are commonly used in expressions of if-else statements. A and B, so Boolean and true when both sides, true when at least one, opposite, true when the single operand is false, and false if the operand is true. Logical operators examples, so given that age is 19, days is 7, and user characters is Q, so age is greater than 16, so that's false, and age is less than 25, which is true. Oh no, this true, so this is true because it's greater than 16. True because both operands are true. Age is greater than 16, true, and days is greater than 10, which is false. So this is false because both operands are not true. Not user character is equal to Q. False because operand is true. User character is equal to Q. Yeah, so that's false because it is true. That's why. Days logged is greater than 30 and less than 90. So this is going to be and. So max cars is greater than 0 and less than 100. Oh, I didn't check this. Num stores is between 10 and 20. So num stores is greater than or equal to 10, and num stores is less than or equal to 20, and. Or num dogs has a minimum of 2 and a maximum of 5. So num dogs is greater than or equal to 2, and num dogs is less than or equal to 5. 5. Correct. So basically with or without the parentheses. And you could do less than 6, since 6 is, this is inclusive, this is not inclusive, this is exclusive. So, which would not include 6 and just go up to 5. If wage is greater than 10 and a wage is less than 18, see, this is telling you that it wants just this, not an equal sign. That's how the other one should be, the ones I was confused on before, where it made it seem like it wanted it different. So we'll do this, and wage is less than 18, like that. Num is a 3-digit positive integer. Example 100, 523, or a 3-digit positive integer, but and 523. Example are 3-digit positive integers, but 55, 1000, and -4 are not. For most direct readability, your expression should compare directly with the smallest and largest 3-digit. So num is a 3-digit positive number. So it's greater than 100. So and num is less than or equal to 989, right? Num is a 3-digit positive number, so it's 100, so equals 100 or greater, so 99 I've got 3 are digit positive integers, but 55 are not. Oh, so because I bet you it's talking about this right here, 999 before it hits 1,000. Or does it include 1,000? 1, 2, 3. No, because 999 is less than, is greater than, and less than our 3-digit positive digit. But yeah, I mean, because if it's less, if it's 99, this is going to be false. Num and num is less than or equal to 99. Okay, well, that's what I have here. So why is it saying I'm wrong? Right? See? So I have and num is, oh my God, that's why. So I had it right. I just put the word is in there. A cable TV provider has regular channels numbered 2 through 499 and high definition channels numbered 1002 to 1499. A program sets a character variable to S for standard and H for high definition and E for error. So if user channel is greater than or equal to 2 and user channel is less than or equal to 499, channel type is S. Oh, if user channel is greater than or equal to 1002 and user channel is less than or equal to 1499, then type H for high definition. Uh, okay, let's see what the output is, and then we'll kind of review it here. Channel type S. Okay, so why did it do S? So we have our input user channel. So if user channel, which is right now is 3, is greater than or equal to 2, so that's true, and user channel is less than or equal to 499, that is also true. So this right here will automatically send S as the output and or set channel type to S and ignore the rest because it just needed the first one to be true. But if it was, 1005, it's going to say H because it's in between this range here. Consider the above example. If the user channel is 3000 or 300, to what does the if statement's expression user channel is greater than equal to and user channel is less than or equal to 499? So that's true. If user channel is 300, does the else if expression user channel is greater than or equal to 1002? That's automatically a false. Get checked. No, it doesn't, because the first one was true, so it wouldn't even make it here. Did the expression use logical and or logical or? So it used logical and. Channels 500 to 559 are pay channels. Does this expression detect that range? User channel is greater than 500 or greater than or equal to 500 or For each pair of statements, does the second if-else statement detect the fringes as the first if-else statement? For each pair of statements, does the second if-else statement detect the fringes as the first? So, 10 is less than or equal to 0. I'll add 10 if 10 if 10 is less than or equal to 0. I'll if 10 is less than 100. Yes, the ranges do not have a gap, so the low end of each range can be implicit. Both if-else statements. If the first branch doesn't execute, temp must be greater than 0, so the second branch's expression can be x is less than or equal to 10. Detecting range is not wrong, just necessary. If systolic is less than 130, LF systolic is greater than or equal to 130, and systolic is less than or equal to 139. So if systolic is less than 30, LF, so yeah, because I mean, no, because it covers the cap. If the first branch doesn't execute, sys must be greater than, oh, so it's, okay, so